Hello and welcome to this new lecture. Together we will learn how to remove nitrates from the well water using the ion exchange method. Let's start by understanding why we might have high level of nitrates in our groundwater. We have different sources that can increase the nitrates concentration within the well or the groundwater. The most common ones are the agricultural sources. So as you know that in agriculture we use fertilizers. So we use chemical fertilizers or organic fertilizers, and those have high levels of nitrogen, and this is essential for the crops growth, but sometimes we use it anarchaically, we use it excessively. And whenever it rains over these fertilizers, the rainwater will actually infiltrate within the soil, and this rainwater is full of nitrates, and it will eventually reach the groundwater. Next, we have the natural or the atmospheric conditions, and we have the formation of nitrates naturally within the groundwater. We have also sewage and septic waste. Notice these are human activities, whether the agriculture or the septic waste, especially if our septic tank is designed poorly, if the soil condition is also poor, and the wastewater is poorly treated, it will eventually reach the groundwater, and untreated wastewater or poorly treated wastewater is full of nitrates. And finally, we have the animal manure that is also full of nitrates, and the same concept, whenever it rains over this animal manure, it will eventually reach the groundwater. The animal manure usually it comes from the farms. So in summary, if your house is near to agricultural activity, to a farm, or you know that the nearby houses or even your house has septic systems, then your groundwater might have high level of nitrates that will eventually come back to you. So the water that you are drinking might have high level of nitrates. Is it dangerous? Is it dangerous to drink water full of nitrates? Well, yes, and we have limits for the nitrates in the water. Different health organization has put limits. For example, the US EPA has also set some limits. For the nitrates, it must be less than 10 ppm, or it is equivalent to 10 milligrams per liter. This is in drinking water. And for the nitrite, it must be less than 1 ppm or 1 milligrams per liter. If you have levels higher than these numbers, this is a red flag and you have to treat your water. What are the health risks? If you have a newborn or a small baby, and if he is or she is exposed to a water with high levels of nitrates, he might get the baby blue syndrome, or what you are seeing here, patches, the blue patches. Also, if a pregnant woman drinks a water with high levels of nitrates, this can cause some pregnancy risks. And also we have the cancer risks like the stomach cancer, colorectal cancer, or the thyroid disease. Now here we have to note that these risks are present after long-term exposure of a water full of nitrates. If you drink once or twice, it is not dangerous. But if the main source of your house is full of nitrates and you are constantly exposed to high level of nitrates, yes, you are at a high risk of health complications. We have several ways to remove nitrates. Now you have to know that nitrates, they come in the ion form, or they are dissolved in water. So if we use physical filters like the scent filter, the carbon filter, nothing will happen, because nitrates are not particles. They will not get trapped. They are soluble in water. So we need to use a more advanced technology like the reverse osmosis, for example, as we are seeing here. These are the reverse osmosis membrane, but this is not the ideal technology for the nitrates removal. This is mainly used to desalinate water for water desalination. Why it is not ideal, though it is highly effective? Because we have lots of water that will be wasted. Also, we have a big capital cost. It is an expensive technology and it requires lots of maintenance and lots of energy consumption. The ideal technology, it is actually the ion exchange method. And as its name suggests, we will have to exchange some ions. So the nitrates will be exchanged with another ion, which is the chlorides. We will see this later on. We will be using a certain type of media to be able to perform this ion exchange methods. And finally, we have the distillation, but also it is not an ideal technology. The most widely used technology and the most common technology, it is actually the ion exchange method. Now let's understand what happens during this ion exchange process. As you can see here, we have a vessel. So we have this vessel and we have another tank that is attached to this vessel, and it is actually a brine tank. A brine tank, it means a tank filled with a salty solution. So we have here actually NaCl. Okay, we have salt. And within this vessel, we have a type of media that is resin. So we have here a resin. So this is what resin looks like. It looks like caviar. So, and attached to this resin, we have chlorides. We have Cl- that are attached to the resin beads. And whenever the water enters, so let's say this is our water entering full of nitrates, and it comes in contact with this resin, we will have ion exchange. So the nitrates will get attached to the resin, and instead we will have the release of chlorides that will leave with the treated water. So in summary, resin with chlorides attached to it in contact with nitrates, this will provoke ion exchange. So instead we will have resin with nitrates plus the chlorides that is released to the treated water. Now from time to time we need to backwash this resin, so the flow is reversed and we will introduce some clean water that will clean this resin from the nitrates, and this is disposed. We will dispose this water into the drainage. Now, of course, with time, chlorides will be depleted. This is why we need to rinse this resin with the brine solution. So also using this control valve, we can control all these stages, whether backwash or rinse or treatment stages. These are controlled and can be automatically controlled with these automatic valves. So we have to rinse this resin with the NaCl solution. So after saturation, the resin is regenerated using sodium chloride brine. Ion exchange method can be used at a residential scale or even municipal scale. So for the residential scale, you can simply use this vessel and the brine tank that we have already seen. You need to add pre-treatment, of course, to remove the particles, the solid particles. Otherwise, you will face clogging. So you need to add a sand filter or even a carbon filter if your water is full of chlorine. So this is the ideal method, let's say, or the ideal system. We have also the whole house filter. So these cartridge filters that have a limited efficiency against nitrates. So this stays the ideal solution. Also, we have the municipal scale. So if we are treating water on a large scale for a whole region, for example, we can have a water treatment plant that works with the same logic. So a vessel filled with the resin that will remove the nitrates and introduce the chlorides. Now let's have a closer look on the media. So the media, it is a synthetic polymer made of tiny porous beads, and these groups hold chloride ions before the treatment. When the water passes through, the resin attracts and binds nitrates. We have several types. We will see these types in the next slide. We have the gel type or the macroporous structures, and we can regenerate this resin many times with brine, so with a solution of NaCl. Now you might think, or you might be asking yourself that, okay, we are removing the nitrates, but we are adding chlorides. We are introducing a new ion, which is the Cl minus. Is this safe? Well, yes, as long as the concentration of the chlorides are less than 250 ppm or milligrams per liter. Finally, let's go through the types of resin. In the market, we have different types of resin. We will be checking for most common ones that are the gel resin and the macroporous resin. We will go through the selectivity for nitrate, advantages, disadvantages, and the best use case. Now, let's explain what is the selectivity for nitrate. As you know, waters, they contain lots of ions other than the nitrates. Selectivity for the nitrate, it means that if my media, the resin, is capable of only selecting the nitrates for the ion exchange. The main competitor for the nitrate, it is the sulfate. So if my water has high levels of sulfates, then I'm facing a challenging condition or situation, and I must choose wisely my media. Let's start by the first type of gel resin, which is the type 2 SBA. SBA, it means strong based anion. The selectivity for nitrate, it is low. So in other terms, if my water has high levels of sulfates, just ignore this type of resin. For the advantages, it has high total capacity in simple water. So this type of resin, it is ideal if I have a relatively clean water and my only problem is with nitrates, so I don't really have a turbid water, I don't have high levels of other ions like the sulfate, so this type of resin is very good and it has a low cost. For the disadvantages, it has poor performance when sulfate is high, as we have already mentioned, early nitrate breakthrough and less stable at low temperatures. For the best use case, use it when your water has low competing anions, especially sulfates. The next type, it is the gel resin type 1 SBA. It has a medium selectivity for nitrate, so it is better than the type 2 SBA concerning the selectivity for nitrate. The advantages, it is more stable and durable than type 2. It works at wider pH temperature ranges. Disadvantages, it is still affected by sulfate competition, not ideal for difficult wells. So if the water is really bad, the quality of water is bad, and we are facing different problems within this water, just choose another type of resin. Use it when you have a moderate quality water. Now let's move to the macroporous types. Let's start by the SBA resin non-selective. The selectivity for nitrate, it is medium. It is highly resistant to fouling and organics. What does this mean? If my water is highly turbid, it is full of particles, it has a high organic matters, choose this type of resin because it has a strong physical structure, but it is not nitrate selective. It has lower capacity than gel under ideal water. So if your water is really good, just don't select this type of resin. Go for the gel types. And it is less efficient when sulfate is high. Use it with waters that are full of organic matters, that has color or turbidity or fouling risk. Now finally, the nitrate selective macroporous resin that has a high selectivity for nitrates. So this is the ideal media if my water is difficult, if it has high sulfates and other anions. Best selectivity for nitrate over sulfate, longest run time before breakthrough, and most efficient in real groundwater conditions or in really tough waters, but it has higher cost and produces brine waste that must be managed. So in other words, if you are using this type of resin, always check your chlorides level so that you don't exceed the limit, and use it with wells that have high nitrate and high sulfate, or in other words, challenging waters. Thank you for watching this lecture. Please don't forget to like and subscribe.